in this video I'm going to explain to you about equivalent fractions. So here are some arrays that I've drawn on the board here. They are all showing equivalent fractions of a half. This first one here, we have 1 over 2. We have 1 of 2 parts coloured in. Here we have 2 of 4 parts coloured in, showing 2 quarters. Here we've got 3 of 6 parts coloured in, and here we've got 4 of 8 parts. So all of these arrays are all showing a half in a different way. So they're not the same, but they're equivalent to each other. They are all a half, and you know it's a half if your numerator is half of what your denominator is. So 2 is half of 4, 3 is half of 6, and 4 is half of 8. So these are all equivalent to a half. You can work out an infinite number of equivalent fractions to a half, as long as you just always do the same thing to the top and the bottom of your fraction. That will keep it equivalent. So for example, in the one before, I just showed you that a half could be the same as 2 quarters. And you can do this by multiplying the top by 2. 1 times 2 is 2. And 2 times 2 is 4. As long as you choose any number and do the same thing to the top and bottom, you will always have an equivalent fraction. So here's another one. You can do a half, and you can multiply the top and the bottom both by 10. 1 times 10 is 10, 2 times 10 is 20. Here's some examples using something other than doubling and keeping things equivalent for half. You could do it with anything at all. So you could have a fraction like 2/7, and to find an equivalent fraction to 2/7, you could multiply the top and the bottom by 2. You double them both. 2 times 2 is 4, and 7 times 2 is 14. So 2/7 and 4/14 would be equivalent to each other. You could do 2/7 and multiply the top by 5 and the bottom by 5. 2 times 5 is 10, 7 times 5 is 35. So those fractions are equivalent to each other.